Okay, so now we're gonna do example 3, and in this case we're gonna do the full Fourier series for the same function we have been solving. So we're gonna do let phi of x equals x in the interval minus L is full Fourier series. Oh, it's full Fourier series is the following. So previously we saw the following formula, right? So for the full Fourier series is phi of x equals 1/2 of a0 plus sum of n equals 1 to infinity. So let's write it like this: an cosine n pi x over L plus b sub n sine n pi x over L. Okay, and here we have a sub n equals 1 over L integral between minus L and L phi of x times cosine of n pi x over L dx. This is n equals 0, 1, 2, and so on. And then this is b sub n. It's going to be 1 over L integral between minus L and L phi of x sine n pi x over L d of x, and this is n equals 1, 2, 3. Okay, so that's what we have to do. So yeah, a lot of integration. So we're gonna do let's start with the easy one. So we need to start finding a0. So a0 is 1 over L, and phi of x is x, right? Times, when n equals 0, this is just 1, dx. So we got 1 over L, x squared divided by 2, and then minus L and L. Right? So we get 1 over L, L squared divided by 2, minus L squared divided by 2. So I'm getting, for the first one, I want to compare, is 0. Yeah, that's fine. Yeah, it's fine. This is 0. Well, you know, I should save my time, right? Because why? Because I'm integrating between x between minus L and L, right? So the area between 0 and L is the same as this area, and this is positive and this area is negative. So yeah, so not very smart, huh? Okay, so now I need to do the integral. So a0 is 0. Okay, so this is done. Now I'm gonna do a sub n. A sub n, but you see, you do it so many times, you just become really fast with this. I mean, at some point it becomes boring. Okay, and that's a good feeling, you know, like uh, it means you know what you are doing, right? 1 over L integral between minus L over L. Phi of x is x, and then I'm gonna do cosine times cosine n pi x over L dx. Okay, so we need to do integration by parts. So we need to go u equals x, so du equals dx, and you call dv, you call it cosine n pi x over L dx, and then you call b equals minus sine n pi x over L, and the derivative of sine is cosine n pi x over L, then the times L divided by n pi, cosine n pi x times n pi over L, without minus, right? Sorry, no minus. The derivative of sine is positive cosine, and then derivative times n pi L will get cosine, yeah. So that's the right one. So I do my integral, a to n equals 1 over L, and again, this is u times b minus integrals of b du, and this is the integral of u dv, integration by parts. So that's 1 over L times u times b, that is x times L n over p sine n pi x over L between minus L and L, u times b minus integral of b du integral between minus L and L. So it's going to be u times b minus b du. Yeah, b du. So sorry, I'm checking. I didn't make any mistake. So for this, yeah, this is an advice for you guys. When you're doing this calculation, you write something, you run one line, you have to check the line and then keep going. Otherwise, if you make a mistake, after that, everything is gonna be wrong. Okay. So a to then, yes, u times b minus b du. Yeah, I think it's good. So once we plug in 1 over L, so once we plug in L, we notice that it's sine of n pi, right? So sine of n pi is 0. So I'm not gonna explain more than that. X times 0. Minus, when I plug in L, the minus also comes out because sine is an odd function. So I got sine of n pi, so I got 0 too. So I got minus or plus, whatever. Anyway, is 0. So this whole thing is 0, right? Minus, I take this out, L n pi, and the antiderivative of sine is minus cosine n pi x over L, and the derivative of this has to give me sine, so my derivative of cosine is minus sine, minus and minus sine n pi x L, so I need to divide by L n pi, right? But when I plug in minus L and L, when I plug in L, I'm gonna get n pi, cosine of n pi, yeah, okay. So if I didn't make any mistake here, I'm getting 1 over L and then minus L n pi, and then I need to plug in L. When I plug in L, I got minus cosine n pi L over n pi, and then plus cosine of n pi L. So cosine is even, so minus in the minus doesn't matter. So I get minus cosine of n pi L over n pi. Okay, so what is this? This guy is 0, right? So this guy is 0. So I'm getting a sub n, a sub n, a sub n is 0. Okay, so yeah, I could save a lot of time with the following observation. I think x cosine n pi x is gonna be odd. Yeah, it's gonna be odd. So that means the integral between minus L and L is 0 because it's an odd function. So this guy, so the function, let's say I call f of x equals, if you wanna save time for the future, let me tell you, x cosine n pi x over L, right? I mean, I should probably do it this way, so I save time, but I, I'm trying to make sure this is understood. So if I replace x by minus x, I get cosine n pi minus x over L. But cosine is even, so this guy is just the same that minus x cosine n pi x over L. So my f of x is this guy. So this is equals minus f of x. So when you have an integral between minus L and L of f of x dx, and this function is odd, that's the definition of odd. F of minus x is minus f of x. Then this integral is 0. Okay, so you could save a lot of time if you do that. Okay. Now, if the function is even, there is something you used to do, but I'm not gonna discuss it. I mean, I just well, let's say if the function is even, the g of x, d of x is even. So you can change this to 2 times integral between 0 and L of g of x dx. Okay, so that's something it might help you to save time, but anyway. Okay, so far the whole thing here, these guys, all these guys are 0. So well, this is gonna be 0 because an times that is 0, but let's put it like an is 0. Okay, and now b sub n, following our formula over here, this is my formula for b sub n here, 1 over L minus L phi of x sine pi of x dx. So that's what I'm gonna do. So so b sub n is 1 over L integral between minus L and L x sine n pi x over L dx. Okay, So we do integration by parts. So we do u equals x, du equals dx, then dv equals sine m pi x over L dx, and then b will be cosine m pi x over L, and then the derivative of cosine is minus sine, so it's with minus, and then I had to divide by L. Oh, sorry, I put m. I don't know why did I put n. N. So it'll be L over n pi, right? So u equals x, du equals dx sine dv equals sine m pi x L dx. So b is cosine m pi x L minus L over n pi. Okay, so we go bn equals u times b minus L n pi. Oh, sorry, I don't want to forget my 1 over L, right? Don't forget your 1 over L. Thank you, somebody told me. Minus L m pi, and then this is u times b, so that will be x times cosine m pi x over L. That's u times b, right? Yeah. Then minus, but minus will be plus. The old b du L n pi cosine m pi x over L b du. That's u times b minus b du. And this is minus L and L. Okay, here we go. So b sub n is 1 over L. Then when I plug in L, I would obtain minus L squared n pi, and then cosine n pi, right? Yeah. Then plus I plug in minus L, I got minus L squared n pi, and then cosine n pi, because cosine is even, so this minus goes away. So is this right? Let's check. Minus L squared n pi cosine n pi, minus is plus, but then when I plug in minus L, I get this one, minus L squared n pi. Then cosine n pi L, yeah, I think it looks good. Plus L n pi, and the derivative of cosine is minus sine n pi x over L times L divided by n pi yeah, and this is between 0 between minus L and L. So I get 1 over L, and then this is sorry, no equal, minus 2L squared n pi, and cosine n pi we already know that is minus 1 to the n, right? And then I plug in minus L and L in this part, and I get plus L n pi. When I plug in L, well, sorry, I have minus here. It gives me minus sine of n pi. Okay, sorry, let's multiply this. L times L is L squared, and then n pi squared. That gives me sine of n pi, right? So whatever is gonna, this guy is gonna give me 0, and the other guy is gonna give me 0 too, because sine of n pi is 0, right? So sine is like this. So this is pi, this is, sorry, this is 0, this is pi, this is 2 pi, this is 3 pi, and so on. So all those guys are 0. So my final answer is Bn equals minus 2L n pi minus 1 to the n. So, or in another way, 2L minus 1 n plus 1 divided by n pi. Okay, so so it turns out that this is exactly the same that, let's write it. So my series finally, so this cosine get annihilated, but this Bn are okay. So my final answer is phi sub x, in this case x, right? So x is gonna be equals to the infinite sum where I am, okay, sorry, here, this is b sub n, and then I have, this is 0, this is 0, then I have b sub n, this is 0, this is 0, so I have b sub n, then sine n pi xl, so that will give me sum of n equals 1 to infinity, b sub n sine n pi x over L, and this is what, sum of n equals 1 to infinity, b sub n is 2L minus 1 n plus 1 over n pi, and then sine n pi x over L. Okay, so really I can take this 2L over here, and that's my answer. Okay, so if you compare with my other answer of the sine function, of the sine series, it's gonna be exactly the same. So let's see. So this is my full Fourier series. This is full Fourier series. And then example 1, give me this one. 2L over pi minus 1n plus 1 over n. And this is because, well, I didn't take the pi, right? So let's take the pi out. 2L over pi sum of minus 1 n plus 1 over the n sine n pi xl. So these two has to agree. There you go. See, it's the same. So why? So they agree because the function is odd. X is odd. Okay. So since note this gives us exactly the same series, the same as the Fourier sine series. Since f of x equals x is odd in minus L. So since it's odd in minus L and L, that's why we got this. The Fourier, full Fourier series is the same as Fourier sine series. So that's kind of an idea, because it tells you that if the function is even, probably it's better to try cosine series. If the Fourier is odd, it's probably better to try the sine series. Or if you just want to make sure, you just do the Fourier series, the full Fourier series, that is called just the Fourier series. And you have to work twice, but you can get it. Okay, so let's graph these guys. Let me put here my computer. Let's grab these guys. So we're gonna use something called Desmos. Okay, so sorry, it looks like I'm not. Oh, sorry, I didn't connect my computer right. Okay, so we're gonna do this. Okay, let me just. So I prefer that you do mathematical MATLAB, but let's say you don't have time. Okay, so I'm gonna teach you this program very fast. Desmos is free, but I'm gonna put a video introducing Mathematica. Since you are UTRGV student, this is free for you. Okay, so Mathematica is free. So, but however, I'm gonna make this video with Desmos because it's free. So we're gonna do first function. We wanna do y equals x, right? So let's call it y1 equals x. That's my function, and I wanna approximate it between 0 and 1. So in a second, I'm gonna make it better. So we're gonna do we're gonna do here. Let's do the sine series. So the sine series I got. So let's see here. So we got y2. Let's call it y2, okay? That's my sine series. So I can write it like, let's say L is 1. So instead of, to make it easy, right? L is 1. I could make it 2. You wanna make it 2? Okay, let's make it 2. So 2L. I have to write more. So let's just do it 1, so I don't have to write so much. So 2 divided by pi, and then and then we put it here parentheses, and then we got sine pi x divided by L, so that will be sine pi x divided by 1. Well, okay, this by 1, so I don't have to write it down. So that's the first one. You see, that's the first approximation. So this is until 1. So let me make it better. Oh, sorry, more amplitude. So it will be until here, okay? So you see the approximation is not great. Okay, the approximation is not great. So that's not a good approximation. So let's add more terms. So we got minus 1/2, and then we copy this sine of pi x, and then this is sine of pi x here, but then I had to, this is times 2, this is 2 here, sine of 2 pi x 1/2 of sine 2 pi x. Okay, so you see that's better. See, this is approaching to 1. Okay, so now I'm gonna do better. So I'm gonna do, my next one is with 3. So I'm gonna do 3 is here 1 3, and then gonna put here 3. See, you see my approximation is getting better. It's around the line. Okay, so let's do it now with my, and so we have to do subtract minus, and then we got 4, and then divide here over here, sorry, over here we divide by 4, and then we got, you see how good it is. And look at, that's what the full Fourier series that is between minus 1 and 1, this is the full Fourier series between minus 1 and 1, and the sine series that is between 0 and 1 match, because they are basically the same, because it's an odd function. Okay, so you see how it's rolling around. Okay, so let's put one more just to, if somebody's effective. So we got 5, and then here 5, and look at that. So it's really rolling around the f of x equals x. So I think it's convincing, right? So you do 20 turns, you know, it's gonna look much closer, but you're gonna show me that in your homework. Okay, so that's when I'm gonna stop the video here. So thank you very much for watching.